Hello and welcome. I'm certainly glad you can join me here. Today I am going to look at some different scenes from different movies and I'm going to analyze the physics of them. We are going to look whether these movies defy the rules of physics or they don't. Let's move on. First of all, we're going to look at Kevin, the boy from Home Alone. In this video, Kevin throws a brick onto Marv. But I'm sorry to ruin your childhood, but Marv, this boy should have been dead. I'm sorry, a man.
My heart and hope to die. Okay.
Look. He throws this brick on Marv's head.
Okay, kid. Give it to me.
Oh, you don't want it to give him to you. But anyways. Boom. I'm sorry, but Marv should have been dead there.
Direct it.
I'll explain to you why later. And he isn't even hit one time. He's hit more than one time. He's hit
You want
one,
Go
you already
ahead.
know
Throw
that.
another one.
Two,
Any better than that, kid?
two.
You're gonna lose.
3, 4 Marv. 4 times. That's how often he was hit by a brick. But he should have been dead from the first brick, and I'll explain to you why now. Kevin is at a height of around 10 meters. The brick weighs around 3.5 kilograms. Let's calculate the physics behind this. If we have a height of 10 meters and a brick weight of 3.5 kilograms, we know that the gravity has a 9.81 meters per second squared acceleration. So, when the brick hits his face, its speed will be 14 meters per second. Why? Well, 10 meters, which is the height, times the acceleration, 9.81, times 2, is 196.2. And then we'll take the square root of that, which is 14 meters per second. This is the formula used to calculate the speed of an object when it's falling down. So, we know the speed. But how much force was exerted upon his face? Well, the formula for kinetic energy is 0.5 times mass times velocity squared. So in this case, that will be 0.5 times 3.5 times 14 squared times 343, which is 343 joules. The 3.5 is the mass of the brick and 14 is the speed of the brick when it hits his face. So this is the force that the brick has before it hits his face, which is equal to 343 Newton per meter, because that's what a joule is. I mean Newton times meter. So that's the amount of energy that the brick will exert when it hits the man's face. His face goes back by a distance of around 10 centimeters, and the rest is all absorbed by his face. So, since force is energy divided by distance, 343 divided by 0.10 meters is 3,430 Newton, or 3.43 kilonewton, which is a force enough to crack a skull and kill you. So, conclusion. Newton's third law has been broken because there was no equal reaction to this action. And he was even hit 4 times, which makes it even more unrealistic. Let's move on to the next scene. In this scene, a bus is running away from the police and they will jump over a cliff, and it's hella unrealistic. The bus goes around at a speed of around 68 miles per hour, which is 110 kilometers per hour. As you can see, wait a minute, how did the bus suddenly go diagonally up? There was no force to push the bus up. Can somebody explain this to me? In this case, since there was no force to push the bus up, it should have not been able to reach the other side. It should have had a projectile movement going horizontally. I'll explain to you why. So, this is the bus that we have. The distance between the two cliff is 15 meters. Sorry, a little of a mistake here. The velocity of the bus is around 30 meters per second. Another mistake. Sorry about that. So, the bus, its movement should be something like this. You see, it should go in a sort of a parabolic movement. Not like this, when there is not even a slope. Oh, that's even more unrealistic. Not like this. It shouldn't go like this. We all know that. There was no slope, nothing to push it up. So, how should it have gone then? Well, we have a velocity of 30 meters per second. By the way, the cliffs were the same height. It was not like the other cliff was lower than this one. See, it is the same height, which makes it even worse. So, the bus is going at a speed of 30 meters per second. And we have a distance of 15 meters between the two cliffs. Which means the time to reach the other cliff is 0.50 seconds. Since it takes 0.50 seconds to reach the other side, like this, it takes 0.50 seconds to reach the other side. This cliff should have been 1.22 meters lower, because 0.5 times 9.88 times 0.5 seconds is 2.45. When you divide that by 2, you get 1.22 meters. It should not have been the same height. It should not have gone suddenly like... PowerPoint. Technical issue. It should not have gone like this. It should have gone like this. That's the movement that the bus should have made. That's why this scene is also incorrect. Sorry about the technical issues there. Now,
I hate to be the bearer of bad news, Your Airness,
one of my
but
favorite
if you don't
movies,
find a fifth
Space
player,
Jam.
your team will forfeit the game.
Our favorite basketball player, Michael Jordan, jumps. And he stays in the air for, let's see, the clock's ticking, you know? 5 seconds it says on the buzzer. He keeps on flying and flying. Oh, wait. As if the flying wasn't bad enough. 2 people stronger than him, with more force than him, jumped on him, and his impulse didn't change at all. He even dragged them with him, which makes it even worse. And let's not even talk about the hands. We'll just even ignore that, because that's just biology. Michael Jordan is a mutant. But anyways, he was in air for 5 seconds. That is already impossible for a human being. You know why? Because let's check in this video. This is Michael Jordan's iconic free-throw line jump, which is a free-throw line is around 4.5 meters away from the basket. He jumps from there, boom, he dunks it. But in the jump of the movie, we covered a distance of 7 meters, going a whole lot more in the air and jumping in 5 seconds, which is even impossible for Michael Jordan himself. But anyways, this scene breaks the third law of Newton. Why? Because every action has an equal and opposite reaction. When Michael Jordan, this is like, for example, Michael Jordan's force, he's jumping towards the basket, and he weighs around 100 kilograms and has an acceleration of around 5 meters per second squared. So 5 times 100 is 500 newtons. So Michael Jordan should have had around 500 newtons. So this, in the movie, it was something like this, but anyways, this should have been Michael Jordan's force. And this monster, 2 of them would jump on him, but we'll take one so it will be clearer. Jumped on him. They weighed around twice his, and they had around the same acceleration as Michael Jordan. So, since they weighed twice, and there were 2 of them, the force should have been 6 times that of Michael Jordan, something like this. That's the force that came from the 2 monsters. And when you look at it like this, and then we'll take it like this, and then this, then this, the second. This is where Michael Jordan should have been at after the jump. At that point, you see? There. But no, he pushed the monsters with him and reached the basket and dunked. Oh, wait. He didn't even dunk it. He just like, woof, with his rubber hands. And that's why this scene is incorrect, because it defies the third law of Newton. In this case, the actions were not equal to the reaction was not equal to the action, because he just kept on pushing and pushing and pushing, and it breaks the law of impulse.
I can't hold it. I'm losing the final
Let's
game.
look at the next scene. Rip Paul Walker.
Gotta get out of there.
So, what happened in this scene? He jumps from this building to the other, through the glass. You might be wondering to yourself, that's even more unrealistic than the past 3 scenes. You might be wondering to yourself, that's more unrealistic than the past 3 scenes, but let me tell you something, this scene can actually be correct. Why? First of all, it follows a parabolic movement, so it has a projectile movement. Doesn't break that law, it goes something like this, you see? Whoosh. And second of all, so the car is going at a speed of around 150 kilometers an hour, which is 41 meters per second. The distance between the 2 buildings is around 30 meters. The stories, so this, oh there we had it. This is around 8 meters high. So, it would take the car 1.28 seconds to fall down, because the square root of 2 times 8, this story is high, divided by 9.81, the gravitational force, which is equals to 1.28 seconds to fall down at 8 meters for the car. So, it also would take the car 0.72 seconds to reach the other side. So you might be wondering, so the car reaches the other side before it's able to, before the gravity is able to push it down enough so that it fits in perfectly in the stories? Yes, it actually happens. But you know why? Look. This might be something that you didn't observe, but look. Here you can see, just as they jumped out, this guy threw a sort of bomb onto them. See, the bomb was slightly up on them, which caused the car to go down even more to make up for that 0.72, for that 1.28 second, to make it around 0.72 second, which is equal to the amount of time that the car needs to reach the other side. So, in this case, because of that bomb, the physics in this movie is also correct. Well, let's look at the third scene, which is Sparta.
It's annihilation. Good Kingston, carefully purged. You should have done the same. This is blasphemy. This is madness. Madness. This is Sparta!
As well as this is correct physics. I'll explain to you why. The reason for this is because the messenger is standing upon the cliff. There's a normal force pushing him up, and also the gravitational force for pushing him down, which means his net force is 0. So he's just standing still. He's an object in rest. The kick disrupts the rest, which is correct with the first law of Newton. An object is rest, stays in rest unless a force acts upon it, and that's the force of the kick. Let's look. The acceleration of the kick is around 10 meters per second. The mass of the kick is around 20 kilograms because that's around the mass of his leg. So 20 times 10 is 200 Newton. That's the force of the kick. That's enough to push him down from the cliff. When he's going down from the cliff, this disappears because there is no normal force anymore. Nothing is on him. Like, go away with this. So the man will just fall down slowly and slowly and slowly. So that's why this scene is correct. The kick was enough to push him down. So the first law and the third law were all of Newton were not broken, because the first law was an object in rest stays in rest unless a force acts upon it, and the third law was that every action has an equal and opposite reaction. So the reaction in this case was that his body was pushed down and fell, and the first law was that, like I explained earlier, he was in rest until the force of the kick pushed him. So we will look at the next scene. The Spartan one was correct. In this case, the main protagonist of Divergent will make a free fall. I'll explain to you how. She falls down. The distance was around 20 meters. Okay, so why is this correct? Because it obeys the laws of a free fall, and also the laws of every action has an equal and opposite reaction. Let's look at it. The height of the building is around 20 meters high. The net will absorb most of the force. I'll explain to you how that will happen. The mass of this girl, is 60 kilograms. The height of the building is 20 meters. As she's falling down, the acceleration of the gravity will just speed her, till here she reaches a speed of 19.7 meters per second, right before she hits the net. The kinetic energy that she will have then is 0.5 times 60, her mass, times 19.7, the speed at which she's just right there, her speed, which is equal to 591 joules, which is the same as 591 Newton times meter. The net then absorbs the force when she goes down, and the net will go down along with her, absorbing a lot of the force, and the net will push her back up. Instead of her body absorbing the force is used to push her back up. Well, the net will go down for like 3 meters, so the force is lowered even more. The force then will be 591 divided by the 3 meters, which is equal to 197 Newton, which will be the force used to push her back up, and also a little bit of the force is absorbed by the body. So that's why this scene is correct. First she falls down, the net absorbs most of the force, she will get pushed back up by the 197 newtons, and she will not be harmed that much, because most of the force was absorbed by the net. And that's why this scene is correct. It obeys the laws of a free fall motion, and also the action and the reaction are equal, because the action was that she falls down, but the reaction is that she will be bounced back up by the trampoline, which absorbs most of that action. Here's a nice little extra scene. You might not want to take this scene seriously, but let's take a look at it. So Bugs Bunny is falling down, and then he stops suddenly.
Lance, let's see you get out in this one. This time you're a diamond.
that falls down instead of the plank, when there is the normal force supporting this and no force supporting that, you know how that can be explained?
I know this defies the law of gravity, but, you see, I never studied law.
Since Bugs Bunny never studied law, he can simply break the laws of gravity. Ha 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 ha. Thank you for watching.